Good morning, everyone. So today we are going to do the experiment E09, polarity marking and testing of single-phase transformer. So before we get started, let me show you the equipment we are going to use. So the first one is a power meter. Now take a look at the panel, and we should see there are 4 connections, 2 for the power source and 2 for the load source. And then the next one is a power source for our experiment. We can adjust the voltage we apply on the equipment. And the third one is a major part of our experiment is a transformer. Actually, it's a set of coils. So if you take a look at the connections, you will see 4 on this side and 3 on this side. And then we take a deep look at the tag. So you will see on this 4 connections side, you will see there are A and B. So there are 2 sets of coils, and each one can stand 100 volts. So together it can stand 200 volts. And the capacity of these this coil is 180. And on the other side, you can see there are also 2 sets of coils. And the one is 9 volts and another one is also 9 volts. So together it can stand 18 volts on this side. So let's start our experiment today. So the first target we need to finish is that we need to identify the structure of these coils. We need to identify which two connections are connected, which 2 are connected, or they are isolated. So we have to know the structure of this transformer. And we are going to use a multimeter, because as we know, these coils, they are every electrical lines, electrical wires, they have resistance. So if we measure the resistance, then we can know if they are connected. If like these 2 have a resistance, then we are sure that they're connected. If these 2 have no resistance, then we are sure they are not connected. So this is the multimeter I'm going to use. And first we set to the resistor side, because we need to measure the resistor. So we set it at 200. Okay. Connect the wire, and we connect it to the transformer. So let's see these two connections. You can see, yeah, there's a reading. So we know these 2 are connected. Next, if we change the connection from this connection to this connection, let's see. Oh, there are no readings. So these 2 are isolated. They are not connected. And again, we can repeat this kind of trial, and we can see like these 2. Okay, there is a reading. So these 2 are connected, and these 2 are connected. And as we already measured, these 2 are not connected, and these 2 are not connected. So we can actually draw a diagram of the connection on this side. It's kind of like this one. And again, we can repeat the experiment on the other side. We can test the connection of these 3 joints. First, we connect it. See, okay, there's a reading, so they are connected. Okay, there's a reading, they are connected. So these 3 joints are connected together, like we show in this diagram. So the first experiment is let us know what is the structure of the transformer. So the next step is, as we can see, we should correctly marking the transformer windings, and we need to calculate the turn ratio, because there are how many turns in each coils, and we need to calculate the turn ratio of the transformer. We are going to use the diagram showing our materials. So first we have to calculate the turn ratios between A and B, and then we have to calculate the turn ratios between A and C. So this is C. So let's start by connecting the equipment like the diagram shows. So first we should connect the power source with the first A transformer. We use 2 wires. Okay. Each wire connects to a joint of the transformer A. Then, as the diagram shows, we have to connect the transformer A and the transformer B. So this is transformer A and this is transformer B. Now we need to connect it together. Connect it together. Okay. Now we have connected the circuit. Next, we have to put our voltage meter into the circuit. So this is the circuit, and we have to use the voltage meter to measure the voltage of the transformer A and the together transformer A and the transformer B. So first we have to use one multimeter. We set it to voltage here because as we can see the rated voltage has been marked on the tag is 100 volts. So we need to select the reasonable range. So here I select 200. Okay. Now let's connect the voltage meter into the circuit. Okay. This voltage meter is responsible for measuring the voltage on transformer A. And another line. Okay, because I connected on the 2 sides of transformer A. And then this voltage meter, I'm going to use it to measure the voltage of the total voltage on the transformer A and the transformer B. As the diagram shows, this is the V2. So again, I use 2 lines correctly connected to the circuit. So this is one. Here, just another one. Now the circuit is connected. So next step, we have to turn on the power source, and to see the change of these readings. And we have to adjust the voltage on the transformer A to 100 volts because that's the rated volts on the transformer A. So we need to check, okay, the power source is turned on, and then we turn on the power source. Okay, we can see a little bit readings here, and please pay attention to the readings. And we are going to adjust the power source to slowly increase the value. Okay, you can see it's almost like the second one is the 2 times of the first one. So we slowly increase the voltage on the first one, slowly, steady.
A few moments later.
Okay, almost 100. You need to be much more slower. All right. Sorry. It exceeds the. Now we can see the voltage readings on the 2 meters, and we need to log them onto the first set of the experiment. So we can see the first one is 100. Okay. Oh, 100.9. Okay. And the second one, okay, is 200. So we need to log them onto our experiment sheet. So this is the experiment we do for the first diagram. Then we need to repeat it. We change the side on the B, and we need to repeat the experiment. So turn off the power source first, okay? And we need to change the connection. Okay, here. Okay, now we have changed the connection. Yeah, so transformer B. And so we are going to turn it up again and see how it changes. Slowly increase the voltage applied on the transformer A.
A few moments later.
Here we almost reach 100 voltage on the transformer A, and on this other second power voltage meter, we can see the readings is always kept at 0. So we take notes. Here V1 is 100 and V2 is 0. Now we use these 2 sets of parameters. We can get the turn ratio of the transformer A and transformer B. Now you have to do the work now. You need to calculate the turn ratio. And the next step, we're going to repeat the experiment. Instead, we are not going to use transformer B, and here we would change it from transformer B to transformer C, the 3 yellow side here. Okay, turn off the power source first. Then we're gonna rewire the whole circuit because we are not going to use transformer B and we are going to use transformer C. Take off these lines. Okay. This is almost. This is voltage meter 2. This is voltage meter 1. Okay, set aside. We are not going to use the transformer B, and instead we're going to use transformer C. So here, this is a power source and transformer A. They are connected. Next, we are going to connect transformer A and transformer C. And then, again, connect the voltage meter onto transformer A. So this is one measuring the voltage on transformer A. Next, we apply a voltage meter on the transformer C and transformer A. Okay. So now we are connected. So the transformer A and the transformer C, we are going to measure the turn ratio between these two transformers. And slowly turn on the power source. Okay, there's a little bit readings here, and we are going to turn on the voltage on transformer A. Steady, slowly.
A few moments later.
Okay, now we have the readings here. The first one reaches 100, and the second one we can take a look. It's almost 100 volts, or 80 volts. Sorry. So 100 volts and 80 volts. Now we take a note. So if we change it from, this is A and B, right? And this is A and C. So if we use A and C, then V is 100 and V2 is 80. So we got this. And then we're gonna change the side on this connection on the transformer C. So first turn off the power source. Okay. Make a slight change on the transformer C. Now transformer C is reversed, and we are going to test the voltage on these two transformers. Okay. So turn on the power source. Okay. Steady, slowly increase the power, increase the voltage.
A few moments later.
Okay. Again, we get another reading. So the first one is 100. And the second one we can see is 120. So we get two sets of readings. Now we can calculate the turn ratio between the coil A and coil C. So this is the first part we are going to do, is trying to help us understand the the tail and head of each coil, and how to calculate the turn ratio of each coil. So okay, this is the first experiment. Now I'm going to shut down the power source. Now let's move on to the second experiment. So the second experiment is about open circuit test. And this is the diagram. So in this experiment, apart from the power source and the transformer we're going to use, we are also going to use the power meter here. So the idea of the open circuit test and the closed short circuit test is to help us understand the structure of the transformers, like the one shows in this picture. So after we conduct the open circuit test and the short circuit test, the parameters we measured in these two experiments are going to help us determine like the copper loss and the core loss in the transformer. So let's start the second experiment. It's about open circuit test. So what's the difference between open circuit test and the short circuit test is on the secondary windings. So in the open circuit test, the secondary windings is an open circuit. It's not connected to anything. But in the short circuit test, the secondary wings is connected to current meter. So first, okay. let's connect the wires in the open circuit test. Take two wires, okay. This is power meter. Oh, this is power source. This is power meter. Connect them. As I instructed at the beginning, you need to see that these two holes. These two holes are for the power source. These two are for the load. So we connect it to the power source. Because power meter can measure the volt and the volt and the current, so we don't use these two these two meters anymore. So this is the power source and the power meter. They are connected. Next, we connect the power meter and the primary windings. Here, load. Oh, I think we are going to use both coil A and coil B together. So, connect them. All right. So we've got an open circuit. And here is the primary winding, and here is the secondary winding. Okay, now we connect all the equipment, and we are going to start increase the voltage we apply. So steady, slowly. Now we can see the reading is changing. Now this one is voltage, this one is current.
A few moments later.
Okay, let me take a picture and. So this is the result for the open circuit experiment. We are going to do the short circuit test. So the difference between open circuit test and the short circuit test, as I have mentioned, that on the second wiring, we need to connect a current meter. So we are going to, okay, thank you. So we are going to use a multimeter, and we change into measure the current here to measure the current. And we are going to connect it to the second winding. Now we have to do the open circuit test and the short circuit test. We can use the results of these two tests to calculate the parameters of our transformers. That will involve some detailed calculations, and you are going to do in your homework. Okay, thank you. That's all for today's experiment.